These are the 10.5 notes for trig. We're going to talk today about graphing something called roses. So they look like little flowers with different petals, and we're just going to graph two different types. The first one we're going to do is a rose with 3 petals, and we know this is a rose with 3 petals because it has a 3 theta right there. And then a rose with 4 petals is going to have a 2 theta there. So this is kind of strange. It actually doubles the amount of petals if it has an even theta, so like 2. So that's kind of what they look like. And we just got to figure out how many petals they have, how big the petals are, and then kind of where they're oriented on the circle on our graph. All right, so for each rose equation, find the maximum and where it occurs. So this is a little bit different. We're not going to be adding the numbers together like we did before because there is only one number out in front. The number out in front, as its positive version, is going to be the maximum. So the maximum is 5. In order to figure out where the maximum happens, we need to do a little bit of investigating on our unit circle. So 5 times the sine of 2 theta. I need this right here to be a number that when I multiply it by 5, I get 5. In other words, 5 times what is 5? Well, that's pretty easy. That's 1. So what I need to do is I need to set up an equation. Sine of 2 theta equals 1 because that's when I'll have my maximum value. And from there, I can use my unit circle to try to find my answer. So I'm going to switch over to my unit circle and look for where sine is 1. Sine is the y value. And I see that happen right up here at pi over 2. So pi over 2 is what I'm going to write as part of my equation. And what I have left is 2 theta equals pi over 2. These are like some equations we solved earlier this semester. Remember, at this point, I would suggest making that into a fraction and multiplying by the reciprocal. Reciprocal is going to be 1/2, multiply it on that side, and multiply it on that side. The 2's will cancel, the 1's will cancel, and we get theta equals, multiply the numerators, pi times 1, multiply the denominators, 2 times 2 to make 4. So I have a maximum of 5, and it happens at pi over 4. So oftentimes I'll say max at, the at symbol, pi over 4. And so when I go to draw my petals, I'll make sure that they are at least out to the 5 ring and that one of them is touching in the direction of pi over 4. All right, let's do the next one. 3 cosine of 2 theta. So 3 is going to be my maximum. And what would I have to multiply 3 by in order to get 3? That would be 1. So I'll take my cosine of 2 theta and set it equal to 1. Now go to the unit circle. I'm trying to find where cosine is 1. Cosine is 1 over here at 0. Okay. So I'm going to say 2 theta equals 0. That's where it happens. And I'll put that over 1, multiply by the reciprocal, just to keep it all the same. And anything times 0 is 0. So I'll say this has a maximum at 0, which means one of the petals will be facing in the 0 direction. So it's like there'll be a petal right there. All right. At this point, you're probably thinking, okay, are all of them just going to be equal to 1? Not exactly. So the next one, A maximum, we don't do maximums as negative, so we're just going to say the maximum is positive 2. And what would I need to multiply negative 2 by to get positive 2? So negative 2 times what equals positive 2? That's going to be negative 1. So I'm going to now set my equation equal to negative 1. I'll go to my unit circle, find where sine, or the y value, is negative 1. Find where y is negative 1. Down here at 3 pi over 2. So I'll use 3 pi over 2. And then I'll multiply again by the reciprocal. Cancel, cancel to get the theta by itself. And I would end up with 3 pi over 4. So I'll have a maximum of 2, and that happens at 3 pi over 4. Each of these first 3 examples would have 4 petals because of the 2 theta. Each one of those would have 4 petals. Let's look at our 3 petals. We're going to do the setup the same way. So example number 4, my maximum value is going to be 4. And that happens when cosine of 3 theta equals positive 1. In other words, 4 times what equals 4? That'd be positive 1. And they're all going to be either positive 1 or negative 1. That does kind of help clarify some things. So now we look to our unit circle. Find where cosine x is 1. Let's find where cosine x is 1. That happens right over here at 0. So 3 theta equals 0. Multiply by 1/3. Multiply by 1/3. Doesn't really matter what I do to the 0. It's still going to get me a 0. So maximum value of 4, and that happens in the direction of 0, which would be all the way to the right. Example number 5, I'm going to have a maximum of positive 7. Well, I need to multiply this negative 7 by positive 1 or negative 1 in order to get a positive 7. Obviously, we're going to need a negative 1. So again, you can see it's always either going to be a positive 1 or a negative 1 because those are the biggest numbers on your unit circle. All right, let's go see when that happens. Sine is negative 1. Here it is down here, 3 pi over 2. So you can see the only places you're ever going to be looking is this location over here, this one over here, this one down here, or this one up here. All the rest of these numbers within here, they're not positive 1s or negative 1s. We also are not doing our tangents. These don't have any tangents in them, so you can ignore any of the tangent values. Right, so this happens at 3 pi over 2. So I'll say 3 theta equals 3 pi over 2. Multiply by the reciprocal. Theta equals. And over here, we can cross cancel the 3's. So I'm going to cancel that 3 and that 3. I get pi times 1 is pi. And a 2 in the denominator. So that happens at pi over 2. Last one, example 6, and then we'll start graphing. Maximum of 10. So that happens when you have a negative 1. Negative 10 times negative 1 is positive 10. Cosine is negative 1. Over here, there's that cosine, so we'll write pi down. And then multiply by the reciprocal, 1/3 and 1/3. The 1s can cancel or just be ignored, and we get pi over 3. All right. So let's go to Delta Math and try to graph a few of these. As we look at Delta Math, you should see your 10.5 notes examples. That's what we want to get to. So we'll do examples 7, 8, and 9. When you open up example number 7, you'll see now you have those 6 options still, and this one on the far left is your roses. So in your note page, I just went ahead and made sure I pointed out what each one of those was so you could easily graph. So we're going to be selecting our rows for each one of these. Let's find the type of graph it is, meaning that it's a rose. And we just got to figure out how many petals this has. Since it's got a 3, it's going to have 3 petals. The maximum, the number in front, is 5. And that happens when cosine of 3 theta is equal to positive 1, right? 5 times 1 is 5. So this 5 times this, which we need to be 1, would get us the 5. Cosine of 1 happens over here on the right. Erase the rest of this stuff. Right here. So, 0. 3 theta equals 0. And even before you multiply by the reciprocal, you can tell that that's just going to be an answer of 0. Let's look at delta and plot a rose with 3 petals with a maximum of 5 that happens at 0. Notice we have that exact same problem right here. So we're going to select the rose. And then it asks you for the number of petals, and it gives you a drop-down menu. The ones we're going to do are either going to have 3 or 4. We're not going to get into these other ones. So this one has 3, so I'll select that, and then immediately you see the rose pop up here. This is the only dot you get to move, and everything else kind of moves along with it. So we're going to put this dot facing the 0, which is all the way towards the right. Remember, 0 is this direction. And we're going to take that out to 5. So 1, 2, 3, 4, and 5. Try to land it as close to you as you can on the line. Make sure you're not off, right? You don't want that. Delta Math gives you a little wiggle room, but not too much. They really do like it to be right where it needs to be. So we have our 3 petals. The maximum value is 5, and it is facing towards the 0. Take a second on your own to try that on your Delta Math example number 7. The explanations talk a lot about different things. We don't really do it the same way that Delta Math does. So I wouldn't spend too much time trying to work through that. All right, let's go on to example number 8. Example number 8 has a negative 4, cosine 2 theta. 2 theta is going to have a rose with 4 petals. So that 2 doubles. All right, our maximum is going to be 4 because of this number right here. And that's only going to turn to a positive 4 if cosine of 2 theta is equal to negative 1. You have to have that double negative in order to make your maximum a positive 4. So we'll investigate on our unit circle where cosine, or x, is negative 1. Cosine is negative 1 right here. So we'll write down pi. 2 theta equals pi. And I always multiply by the reciprocal. You could divide by 2 if you wanted to. Cancel, cancel. Theta equals pi over 2. Let's go over to our problem on delta. You can click next section. It should take us to example number 8, where we have negative 4 cosine 2 theta. We'll select our rows. We'll change our number of petals to 4 petals. You can see it change at the bottom in our graph. And then we'll take our point. We're going to have to bring it out to 4 and in the direction of pi over 2. So pi over 2 is up here at the top, right? Pi over 2 is up here. So we're going to take our dot out to 4. So think about taking it 1, 2, 3, 4 steps in the direction of pi over 2, just like we would plot a point. You end up with something right there. Pi over 2 up towards the top, 4 spaces out, that's where your dot goes. Again, they give a lot of instructions here, and if you want, you can kind of slide this over to see why it happens. Has to do with the way the cosine graph works. There we are. All right, let's try the last one. Take a moment, see if you can get the information for problem number 9. Decide what type of graph it is, what the maximum is, and where that happens. Okay, so that should be your setup. You have a rose with 3 petals, maximum of 2. We need that 2 to become positive, so we multiply it by -1. So I'm trying to find where sine of 3 theta is -1. This happens at 3 pi over 2, all the way at the bottom. Down here, 3 pi over 2. So I'll put that over 1, multiply by the reciprocal like I always do. And here my 3's are going to cancel out. And I'm left with pi over 2. Pi over 2. Let's go over to delta and see if we can plot that. Select your rows. 3 petals has already been selected, so we're good here. You want to go 2 out in the direction of pi over 2. Remember, pi over 2 is all the way up at the top. So 2 out in the direction of pi over 2. 1, 2. It should look something like that. All right, nice work on those. If you have any questions, let me know.